So this is an end haul alignment. We've got a whole bunch of material to move. And in this part of the webinar, what I'm going to do is show you how you can add smart pits, and they will tell you the best place to put your waste pits, in this case, spoil pits. It's a bit of an artificial example because really on this steep side hill, there just is no place to put a spoil pit. But we're going to make some stuff up so it at least looks interesting. Okay, so this design is a vertical, well, the vertical alignment is simple. It's just a continuous grade from one end to the other. And the horizontal was adjusted so that it's basically on full bench cut all the way along. So we got lots of material. And again, let's just update the, I can do that here, update the recost so we can see our Opti Haul. So let's take a look now while we're looking at pits at this Opti Haul diagram. That's another thing I wanted to cover, and I think running out of time, so I'm going to kind of kill two birds with one stone here. Notice that because we're cutting all the way up, we've got a lot of material left over at the end of the alignment, and this Opti Haul diagram is telling me that we're moving it here, there's a pit there, and here, there's a pit there. Those are called artificial pits or art pits. That's what it says in the hover tip. They are created to allow the recost to balance materials. On a steep road like this, a forest road, you probably aren't going to move material uphill. It's more expensive than pushing it downhill. So I'm going to change the way this thing calculates. I'm going to put in a constraint. This is for the Opti Haul calculation, and I'm going to tell it to only move material backwards or downhill. Recalculate. Watch what happens to the mass haul diagram, or pardon me, the Opti Haul diagram. Now everything's moving downwards. But we still are putting everything at the end of the road in this artificial pit. So let's put in some actual spoil pits. Now I got those options from here. I could also get them from here. Pits. And there's yet another place you can add pits too. So let's put one at the beginning. Waste pit, good. Let's put one at the end. Okay. Now watch what happens. First of all, the one at the end is not going to get used. We're not allowed to move material uphill. So let's change the station for that one to be, say 525. Okay, just pick a number. Okay. So there's the pit at the beginning, there's the pit at the end, and it's using both of them. This is reducing the amount of haul required. I'm going to add in a couple more spoil pits. You can also add spoil pits using this assign by range. There's the same pits dialog box, assign by range pits. Let's just put in a couple more. So I'm going to add a waste pit at station 150. And I'm going to add another one at 250. And I'm going to add one at 325 and 4. How about 400? Okay. Okay. So now the software is using all the spoil pits. Now what if it costs money to build the spoil pit? Is this still the cheapest way for the haul to work? Maybe not. Let's put in a cost value for each pit. That's right here, site preparation. So I tried this a while ago, and 10,000 seems to make it interesting. If it's too big, it's going to use one pit, and that'll be the first pit. If it's too small, it's going to use all the pits. But 10,000 seem to be kind of in the right ballpark. Of course, these numbers don't have to be the same. They could be different. Realistically, you scope out where your spoil pit's going and you figure out how much it costs to open the pit, clear the trees, maybe remove the overburden, maybe build a berm, I don't know. Anyway, it costs money to prepare the pit. Recalculate again, recost again. And now you can see that it's actually cheaper to use just this pit, costs 10,000 to open it, and this pit costs another 10,000 to open it, and skip the ones in the middle. It's cheaper to move the material than it is to open the pit. So that's the concept. Whenever you do a recost and update your Opti Haul diagram and your mass haul, the software is doing an optimization. This optimization does not require the Software Optimal license. It comes with RoadEng. We're not optimizing the alignment. All we're optimizing is the haul of the materials. And that's the concept. You put in a bunch of pits. You define how much it costs to open each of them. And the software will choose according to its cost, unit costs, which one is cheaper to use, or multiples. Yeah, don't forget that we put in the cost for the pit here. That's just a single number. But there's also unit cost being used to calculate cut, fill, and haul. And you need to set these up too if you want to get accurate results. But the defaults aren't bad. You're going to get reasonable results. Okay, next step, let's look at more detail of what this Opti Haul diagram is showing. First of all, like the mass haul, there's a concept of free haul, overhaul, end haul. In this design, we don't have any end haul. It's all going to a fairly close pit, so the haul distance is small. And the value for the free haul versus overhaul cutoff is determined in your costs here and here. There it is, 150. That depends on these numbers here. There's a simpler way to do this. You can change it to use free haul control, in which case you only get the free haul distance and a couple of other cost parameters, and then it calculates the other cost parameters. The default settings are similar to this, where it's got 3 machines using different loading and hauling costs. If I change the loading cost for the scraper, the middle machine, and hit update, it changes where that cutoff is. So I increase the loading cost for this machine, and it said, well, that means that it's cheaper to use the first machine, usually a bulldozer, for a longer distance. But if I reduce the cost of hauling, that number moves back again. So you can see how it works. It's just trying to optimize which method of haul it should use for which distance of haul. And that gets displayed in this graphic. So the green here in the mass haul is your free haul, the yellow is overhaul. Similar in the Opti Haul graphic, the green is free haul, the yellow is overhaul. Hover, you can see the amount. So we're hauling, past this point, we're hauling 41,000 or 4.1 thousand. Past this point, we're hauling 92. It's going further, 9,200. And these numbers can be copied to the clipboard. Sometimes it's nice to put some numbers on the right-hand side here to reduce the number of categories you get. Let's just see what it looks like this. So the graphic is showing me how the material is moving and how much is moving. The table, there it is showing me where we're cutting. So, oh yeah, see that number, 2.1 meters, is kind of useless. Let's just do that again. Copy to clipboard. Let's only look at volumes greater than 100 cubic meters and distances greater than 50 meters. It'll combine some of those numbers. That's better. So there's my detailed haul table. It's telling me that I'm taking 274 cubic meters from between station 490 and 500, so it's kind of near the end. And I'm moving it to 470. Okay, that's an actual movement from the road to the road, so there's some fill involved, and it doesn't move very far. It's an average of 15 meters. The rest is going into pits, and you can see that, you know, from there's about 5,000 cubic meters there moving from 500 to the end. So that range is being moved to pit 5. There's more being moved to pit 5. This is slightly longer distance, so it's closer to the end, but it's also going to pit 5. And then the rest of it's going to pit 1, and we got some near going to pit 1 free haul, and we got some far going to pit 1, it's overhaul. So this table gives you numbers, cut ranges, fill ranges, distances. Obviously, when it's going to a pit, the range is not much. It's a point. Well, I really did go longer than I was expecting. That's the Opti Haul diagram. It's really just an extension to your mass haul diagram. It shows you the material movement instead of the accumulated material. So it's really just taking these arrows and making them more graphically correct. And as you move along this thing, it's picking up material, and you can tell how much material by just looking there. So it's kind of, you know, that would literally be the machine number 2 moving down the road with material. That would be machine number 1 moving down the road with material. And then it shows the pits, and you can hover to see the volumes in the pits.